Back to the Future of AI, a podcast time travel about artificial intelligence in companies and society with AI pioneer Alexander Thamm.
Today we welcome one of the most influential minds in data and AI. Stephen Brobst is the Chief Technology Officer at Ab Initio Software and was previously the longtime CTO of Teradata, where he helped grow the company from a $200 million startup into a multi-billion-dollar global leader in analytics. Named one of the top 5 CTOs in the US by ExecRank, Stephen holds numerous patents and has authored hundreds of publications on data management and machine learning. He studied at MIT and Harvard and served on President Obama's President's Council of Advisors on Science and Technology, contributing to the US big data strategy. Welcome to Back to the Future of AI, Stephen Brobst.
Yeah, Stephen, it's totally amazing to have you here. Thanks for joining our podcast, Back to the Future of AI.
Thanks for having me.
So, we talked about the scheme and we want to learn a little bit about the history. Most of our listeners actually and viewers don't have this profound experience in AI, and there's so many AI experts around now. So it's just so amazing to go through this journey with you. And I remember we met, almost 20 years ago. So can you take us a little bit on your journey? How did you came into the field? And
Well, originally, actually, I started in scientific computing, doing advanced physics and hydrodynamic simulations and very large data sets, but really scientific computing. And that was when I was on the West Coast working in large science laboratories. Then when I went back to the East Coast for MIT, the science labs out there weren't the same quality as the science labs on the West Coast. But I'm a very hands-on person, so I wanted to build big systems, not just do theory. And the largest computers with the most interesting problems were on Wall Street. So I started building trading systems, and that was my first sort of shift from the scientific world into more commercial world. Now, trading systems are less complex than advanced data warehousing and so on, because the types of data that you work with are more narrow, but very high speed requirements and very sophisticated analytics and so on. That sort of brought me into that world. And then from there, I evolved into more traditional data warehousing and a bunch of startup companies. We took some public, we got acquired. So I was a serial startup person, but always in the field of data and machine learning, et cetera, et cetera.
So, Stephen, where did this fascination for the topic come from? Like, do you have any like epiphany moments or so? You can still remember how you got excited about the field?
I think that it was really about decision making with data, because at the same time I was doing my PhD work in computer science, I ended up doing an MBA and thinking about strategic uses of technology. And in the end, the technology is not the interesting part as much as the data. And how do you drive decisions out of data and make better pricing decisions or supply chain optimization decisions and so on, and started bringing together the computer science and the management strategy. And that's really where it came from. And data warehousing in the end isn't about technology. It's about empowering decision makers with the data so they can make better decisions.
That's just beautiful. I mean, like I would never compare myself, obviously, to your journey, but for me it was the same. Like I felt that a lot of decisions this is like 20, 30 years ago for you, I guess maybe even longer, were not really done by what is the best thing to do, but it was more like who has the most influence or so in a company. And this always kind of nagged me, the beauty about the truth that is in the data, which is obviously mostly hidden as it's not primary.
Yeah, we call this the hippo principle. That, when you're not using data, how do you make a decision? Highest paid person's opinion. The hippo principle, which is a very bad way of making decisions, because usually the highest paid person isn't even an employee, it's some consultant who doesn't even have to live with the decision afterwards.
Exactly.
So this is really not a good way to have a culture of decision making. And people sometimes talk about, yes, we're data-driven. When the data agrees with me, we use the data. When it doesn't agree with me, then I, use the gut of my stomach. Or you use data to justify your decision after the fact. And these are dysfunctional cultures. So there's been a lot of work by people like Eric Brynjolfsson and Tom Davenport that if you truly use the data for decision-making, you can quantify the performance difference versus enterprises that don't use the data for decision making.
It was actually competing on analytics by Tom Davenport?
Davenport,
right?
yeah.
Davenport. That is a book that kind of, made me go into the field. And for me it was in marketing where everything was super fluffy. Half of the money spent is, I don't know, not really giving the results. We don't know which half, or that somehow this is the quote, right? Yeah. And then, but it's funny because I think also with the hype about AI and agentic AI and everything, but what you say is basically what that's always been about, right? You want to have a better company, which ultimately I think you might do because making money, but also for maybe improving the world in some way. But it originates from the knowledge that is hidden in the data and the way you extract that. Yeah, used to be, I don't know, OLA, BI, data science, data mining, machine learning, AI, agentic AI. So, yeah, but the schematic is always kind of the same, right? Or
well, I think it's evolved a bit.
Sure.
So, in the early days, if you look at the maturity of the marketplace or even individual companies, typically they start with reporting.
Yes.
Just define the key performance indicators, create reports so you can at least measure your results. And this is where you also start to discover the quality problems in your data and so on. They surface in that phase one. But once you create the report, it's the answer to questions you already know. And it becomes much more interesting to evolve from that first phase into what I would call the analysis phase, where it's not just what happened, but why did it happen? And to be able to drill down and do the data R&D and do much more exploratory work. In the end, data scientists don't care about reports. That's the answer to questions we already know. And the data scientist's hardest job is not to get answers, but to find the right questions. And that's fundamentally the analysis part. And then you evolve from analysis to prediction. Okay, so now I understand why it's happening historically, but how can I use that to project the future? And you mentioned this data mining term that's been around, for decades. And, we're all excited about AI right now, but AI is, 75 years old. It's now only accessible to most companies because the economics have changed, partially because of hardware innovation like NVIDIA, but actually most of it is software innovation. The math actually hasn't changed very much. No. But how we translate the math into the hardware. I mean, NVIDIA chips were not designed for AI, although that's their primarily market value today, but they were designed for video games.
Exactly.
And some smart computer scientists figure out how to take the high-performance, very cheap bitwise analytics and apply that to neural networks with binarized neural networks. And now all of a sudden we've got orders of magnitude higher performance, lower cost that allow neural networks to be applied at scale rather than just these toy academic projects or, hidden in basements from, only government agencies or very sophisticated with very deep pockets, Wall Street companies and so on. Now neural networks can be accessible to almost anyone in a reasonably cost-effective way. But the trick really is not the AI math, it's the data. And this is where people get confused a little bit. Yeah. Differentiation is not the AI math. Everybody has the same AI math, same libraries, the same open source frameworks or frameworks provided by the cloud service providers. Everybody's the same from the math point of view. The real differentiation is how well do I manage my data? And this is a little bit of a nuance, but my metadata. Because the data is only half the story. The metadata actually gives the context for the AI to do the right thing. Yes. So if you use AI directly against the data, the accuracy and the likelihood of hallucinations is problematic. But if you have the metadata that helps provide the guardrails and does the grounding for your AI algorithms, particularly generative AI, you get much, much better results. And metadata is a little bit complicated to explain to the novice, non-technical person, right? Because, we've convinced the business, and they, I think, will agree, we have to fund data. Data is the differentiator. So we got that, and we're funded. But now we stick out the tin cup and say, now we'd like you to fund the metadata. I say, what? What is metadata? Oh, metadata is data about data. And for a business user, that just makes their head hurt. And so you have to explain it in a different way, that the metadata is the context for good decisions. It gives you the definitions. And historically, metadata was not that interesting. It's more like documentation.
Yes.
I have a business glossary that explains, what all these terms mean and so on. How boring is that? So humans, they might read it once, but then they don't look at it again. But this business metadata is absolutely critical for agentic AI to have the context to make good decisions. And without that metadata, you get very bad decisions. And we have to tie the business metadata to the technical metadata.
That's pure gold. Yeah, I hope everyone got that. And there's so much I can touch upon. Maybe just referring to how we work as humans and also like all the animals. So the whole world functions with metadata, right? So if you see something yellow, even if you are, I don't know, a fox or so, the metadata and the information can be dangerous, right? I mean, also what Yannick Kohn says with the meta model. Yeah, and I personally also don't believe in this whole AGI kind of fantasy-ish, or maybe it will work, but more I think on some kind of how human intelligence also works, and that's why also coming back to the whole data quality issue. I always found it hard to discuss about data quality because there is no, I think obviously like. There's some data quality KPIs like are the columns filled or so that makes universal sense. But then coming from, can we do the use case with the data always depends on the use case, right? And in the context,
I mean, the goal isn't perfect data. Perfect data doesn't exist. If someone tells me they have no data quality problems, either they're lying or they haven't looked.
They haven't extended.
And so even if you had perfect data, you would have paid too much for it. So it's not the goal. The goal is fit for purpose, to your point. It's fit for purpose for a particular use case. So if my use case is financial regulatory reporting, my tolerance for data defects, at least in the money part, is going to be relatively low.
Yes.
But if it's marketing use case, directionally correct is probably okay. So the level of investment that I'm going to make is different depending on the use case. But data quality has an interesting characteristic that if you invest and you improve data quality, it improves for whatever your next use case is, but it improves for all future use cases. So the payoff for data quality is generally very good, but it shouldn't be a data quality cleanup project. It's the wrong way to do it. It should be continuous improvement.
Exactly.
Process. So you're measuring, you put in data quality controls. Historically, the data quality controls might have been dreamed up by some subject matter expert. But now generative AI with appropriate training, appropriate metadata context can actually create the data quality controls aligned to a particular industry, aligned to a particular company within industry with much less manual involvement from humans. Now, humans still should look at the output of the generative AI and say, yes, that it makes sense what I'm doing. And this is actually critical, that the output of the generative AI should not be code, because code is not understandable by the subject matter experts. It has to be using the terms of the business concepts. And this is where the business metadata comes in. And then that business metadata connects to the technical metadata, so you can translate it to the underlying physical implementation of the data and do proper measurements and so on. So you start to see how the different pieces of metadata come together as a whole, because when you have a whole bunch of point solutions, they don't come together well. Right, your data quality solutions over here, and your ETL solutions over here, and your federation solutions over here, and you're just trying to replicate and synchronize the metadata across them. It becomes very, very ugly.
I think that's also the reason why the big data era kind of failed on that promise. Yeah, like put all the data in one data lake and then everything will be great. Yeah, and I mean, it helped us to store more data and like be able to do this also economically, but the results were not there. Yeah, I also believe, remember in data mining, fantasy was, find the needle in the haystack if you just buy our whatever software consulting, whatever that would be. Yeah, and but the context was missing of how was the data generated. Yeah, was the data generating process?
Not only the context, I would argue that the whole approach was wrong. So this big data phenomena that you describe, people were measuring success by how many petabytes they stored on disk drives.
They can shove it in the garage.
Good measure of cost, but a very bad measure of value. And so you had people going to all these conferences talking about my big data is bigger than your big data, and so it's very macho.
I have faster data and more, and all the V's that came up. Yeah, the first 3 V's and then 7 V's, like veracity and variety, and
the one that they forgot was value.
Exactly.
And that's the most important one. So you don't start this whole idea of data as an asset where the goal is to accumulate more and more data. That's actually the wrong approach. We should really be thinking about data as a product, and it's focused on consumption, not storage. Storing data that doesn't get used is just cost.
Exactly.
So we need to start from the other side. We need to start from value. What is the fundamental value proposition that I'm trying to create for the enterprise? And that's not about technology, and it's not even about data, but eventually you have to say what data is going to enable me to realize that value proposition. So you don't work from the data forward, you work from the value proposition backwards. And that data has service level requirements, like I need, for it to be relevant, it should be loaded within 1 second or 1 minute or 1 hour or 1 day, whatever it is. And it should be this level of data quality, to your point earlier. It should be this level of availability, this level of performance. So you have the service level contracts, and then you start working back, okay, now how can I fulfill that data product requirement from the raw materials that I get from my source systems, and do that with trust so that I see complete lineage and transparency and some of these points you mentioned earlier.
I have a friend, he's a totally DIY guy, right? And he does exactly the big data phenomenon. He goes into a Home Depot store or so, and he just buys, I don't know, sand or some building materials if they are on sale, and he puts them in his garage because then he might need them sometime. And basically, everything is really messed up, and his house is never finished. Yeah,
we have a term for that. We call it a hoarder.
Exactly.
You're hoarding. And there are a data hoarder, the people that hoard data, and their self-worth is measured by how much data they have. And in the end, that's cost. It's not value. And you had in the big data phenomena, people were dumping data very often into Hadoop distributed file system. They weren't doing curation. They weren't really creating data products because the bytes were on disk drives, but they were unusable by a mere human. A business subject matter expert couldn't really do anything with the data because it was uncurated, ungoverned, and messy.
But now I see we have sometimes the other problem that we have so many use cases floating around in the companies with the, I don't know, prototype trap or however you call that, and all of the particular use cases have a certain ROI, but going into larger, let's say, metadata or data cleansing projects, nobody's wanting to take the investment, let's say. Yeah. So how can you solve this head and egg problem?
Well, I think that the build it and they will come approach for a data warehouse or a data product is the wrong answer. You start with a business value proposition. It has a value. You understand that if I deliver this, we're going to have value. And you're going to prioritize. You're not going to do a big bang. You're going to get the data just that you need for that. So using Agile DevOps best principles, Yagni, you ain't going to need it. Don't go put data in your data warehouse because you might need it in the future, because it's better to defer that decision until you actually need the data. Now, when you put data in a data lake, I would argue, I use this touch it, take it principle. If you touch a file, bring the whole file in, because it's more cost effective to bring it all in at once in a completely automated basis than to argue about which 55 of the 62 fields you're going to bring in.
Yes.
But you're storing it in cheap storage, and you're not actually doing the data modeling and all that heavy stuff on that. So that's cheap. But when you bring data into data product, there's an investment you're going to make in governance and curation and so on. So you need to be thoughtful about making those investments, and you need to deliver with a product life cycle that's measured in weeks, not months, and certainly not years, because a lot of those big bang data warehouses failed because they didn't deliver within the time frame that business people cared about. If you promise me something 18 months from now, that's like another world.
This is so gold, because I just honestly today I talked to a very large insurance company, and they're now building a agentic platform. And I asked them, like, but what are the use cases? Like, what are you then doing with it? And they're like, yeah, we don't know yet so much. We will build the platform because then we have the compliance and data quality issues in place, and then we go out and find some, operating.
That's the build they will come approach. So Eric Brynjolfsson wrote a very interesting paper about innovation versus governance. And the people that you just described, without knowing their name, they would be categorized as fashionistas. That the technology is very sexy and very interesting, and we want to go play. And IT people love to chase sexy technology, right? They're like 8-year-olds playing football. Not American football, but real football. You look at 8-year-olds, or at least in the U.S., maybe not in Germany where you start early, but you kick the ball and they all chase the ball.
Exactly.
There's no teamwork, there's no strategy, there's no passing. They just all chase the ball. And IT people are like that. Oh, there's big data. Let's go chase big data. Oh, there's Hadoop. Let's go chase Hadoop. There's AI. We don't know why, but everybody else is doing it, so let's go have fun. And this is very fun. Your LinkedIn profile looks very nice, but there's no value created. So Eric Brynjolfsson observes that if you have innovation, and you need innovation, you also need governance. Now, we think of governance as this bad thing. It's, bureaucracy and slowing things down and saying no. And innovation is saying yes. Innovation is moving fast. Innovation is no rules. The reality is you need each other. So if IT people, who are typically the fashionistas, are working on a project where there's no business person that cares about the outcome, they should stop right now. Brynjolfsson, has this 2x2 matrix. So if you have low innovation and low governance, that's the loser category, right? Because you will not be in business for very long. He doesn't call it loser. That's my interpretation, but he's more polite than I am. Then you have the fashionistas, which is a lot of innovation and no governance. You can also have high governance and low innovation. That's the cash cows. So let's take fixed line telecommunications. There's no innovation there. Should you shut down your fixed line business? No, it's a cash cow. You make a lot of money. The copper in the ground is amortized a long time ago, and there are a lot of, I'll say, older people, not to be ageist, but that's who they are. They still have these fixed line phones in their house, and they pay 50 euros a month to have these fixed line phones, and it's ridiculous to have them, but they have them, and they'll pay till the end of their days. This is not a growing market, because those old people will not live forever, and my little sister will never, ever have a fixed line phone in her home. The last time I had a fixed line in my place of living was, in my university dorm room, and that was a long time ago. And so it's a cash cow business, doesn't go away. It's just like, branch banking is cash cow. Should you shut all branches immediately? Well, you're going to lose some customers if you do that. So you have to look at, for your particular region, what is the demographic of the people? If you shut down the branch near where my grandmother lives, she will stop banking with you. She will take all her money out and she'll bring it to somebody else. And so do you want to put those assets at risk? Whereas my little sister wouldn't go in a bank branch if you paid her. And so
Germany, we have to do sometimes to do some physical underwriting or something.
No, you should not have to.
I know. That's a different
digital
topic.
transformation, right?
Yeah,
I mean, there's no reason why you shouldn't have a DocuSign. There's no reason why you should ever have to go to a physical branch, I would argue. But in the upper right-hand corner, it's called the digerati, the people that are sophisticated about using data, using technology to create business value. And this is where the business people and the technology people come together. Yes. They need each other. The business people need the tech experts to help them understand what's possible. But the tech experts need the business people to understand how you're going to monetize those possibilities. So they need each other. And those are the people that perform better. And Brynjolfsson would say that the profitability of the digeratis is 4 to 6% higher than any of the other quadrants minimum, and it's profit, it's not revenue.
Yeah.
So it's a big deal.
Do you see like throughout the years that there's an emergent of those two types of leaders, let's say technical and business leaders? Do you see that they are like growing together, or do you?
Growing together sometimes, but very often it's collaboration.
Okay.
The same person doesn't very often have both of those skills, and you can't necessarily expect them to learn it. It's, I feel very, privileged that I was able to, and I won't say it was by planning or some great foresight, but I ended up having both those sort of aspects of training, the very deep technology training together with the business strategy, but it's unusual to have that in a single person. So you need partnership. You need partnership between the tech experts and the business experts. And the business person has to be open to the idea of the technology, and the tech person has to be able to communicate effectively without using tech speak. So I would argue there's no such thing as a technology decision. There's only business decisions. And the technology person's job is to translate the technology mumbo jumbo into something where a business decision can be made.
I see an interesting phenomenon is happening now in some European companies where CIOs become CEOs. Right, so this has never been the place before, because we are like in manufacturing, engineering kind of culture. So you basically are either building cars or designing cars, or like developing cars. But then this is the trajectory to become CEO, right? So, but now, and the CIOs, they were more like, you have to manage the cost, and basically everything has to run. They were like more operating kind of people and cost driven. And then we had the CDO era, where like, hey guys, let's do something. Basically, people from Silicon Valley come over, explain stuff, get frustrated, leave. Yeah. But now the CIOs are becoming more like, I'm just not just responsible for operating stuff. I'm kind of innovating and like asking questions about why is the business doing that? Does it make sense? Yeah. And what I think like, we used to have this principle like you can manage everything, right? Like if you are a good manager in a Fortune company, you can basically manage each department because it's just managing people, right? So they don't have this like deep understanding of not just technology, but also what was actually being done there, because they have their people to do that, and they have to just keep them in check, right? But I mean, I see it a little bit. This is more intertwining, and also it's more important now to have a technological background, at least to a certain extent, because you have to be able to understand what's possible with AI in order to transform.
Or you have a partner that helps you understand it. You don't have to understand it deeply yourself, as long as you have someone who is a trusted colleague and you can together brainstorm with them. I don't have a strong confidence in individuals making all the decisions by themselves. I think that smart people working together are much more effective than one person trying to do everything. And so I like small teams. I don't actually hire quote unquote individual contributors. They might be the smartest person on the planet for doing some AI math algorithm for a transformer neural network and so on. But if they can't communicate and collaborate with other people, I don't hire them, because in the end, they're not going to be a high contributor to the overall organizational performance. I want small teams of people who complement each other. If I listed you my criteria for hiring a data scientist, there would be no single person that would meet all those criteria. So you hire a team of people that have those different skill sets, and they complement each other. And you hire for diversity. You hire for skill sets that complement each other. And by diversity, I mean different backgrounds, different gender backgrounds, different age, different race, different religion, different sexual preference. However much diversity you can bring into the team, that creates energy. Because if everybody thinks the same, then you get this group think, and you don't actually innovate as quickly. There was an interesting study done at MIT that showed on a data science team, if there's at least one woman on the team performs measurably better than all male data science teams. And many data science teams are male dominated in Silicon Valley and elsewhere. And that's problematic because you're missing insights and you're missing ways of thinking and challenging the team, because you need to challenge each other. And you can't challenge each other if you're all coming from the same perspective, the same baseline. You have to have different baselines, looking at things in different ways.
It's funny how this is actually proven, and also a totally natural phenomena, like that helped like living itself to evolve all the time. I mean, like then, dinosaurs died, and then some mammals survived, and some plants survive, and some don't, and everything, right? And then some are neglecting this fundamental structure.
Well, it's well shown that diversity in the gene pool creates stronger species,
surviving,
right? of any species.
Yes, yeah, it's interesting.
So we need diversity in the teams. We need diversity in the gene pool. We need that. Yeah.
So let's go back to the questions. I got carried away a little bit, but no, I think it's just, maybe let's go a little bit more on what was your motivation and with like developing Teradata and the data warehouse. I remember the data temperature principle. I loved this at the time, and then you have like the journey to Ab Initio. Like, what were the thinking or the evolvement steps in your career that followed until?
So the thinking was really how to solve large, complex problems. Right. So at Ab Initio, one of our sayings is, our goal is to make complex things simple. We do the design thinking up front to make solving very important, complex problems easier. And scale is one of the fundamental boundaries that makes things hard. But it's not only scale, it's also complexity, it's also speed. You need to be able to handle all of these different dimensions. So my PhD research and pretty much my whole career has been focused on how do you do things in a more cost-effective way, in a more agile way, in a way that creates value more quickly for enterprises. And the value is not the simple stuff. The value is the complex stuff, but we have to make the complex stuff simple so it's accessible. And at MIT, I was in what's now called the Computer Science and AI Lab. And you mentioned earlier Thinking Machines Corporation. So the founders of Ab Initio and myself, we all worked together at Thinking Machines Corporation, building one of the first, I would argue, the first AI supercomputer.
So cool.
And most people have never heard of Thinking Machines Corporation, but most people have actually seen it.
Yeah.
Because if you saw in Jurassic Park, that computer with all the red flashing lights, that was not a stage prop. That was actually a connection machine, which was the massively parallel processor that was based on the PhD thesis of Danny Hillis, who did his PhD in the AI lab at the same time I was in the laboratory for computer science. And so that then became commercialized in Thinking Machines Corporation. And so this is a very expensive, very high-end machine. Think about 65,000 processors doing sophisticated AI inferences and so on. And this is late 80s, early 90s. So this is a long time ago.
Cool.
And only very, very deep pockets could afford this kind of technology. And, eventually the budget for that ran out after the Berlin Wall fell down and Russia was no longer the enemy. So we didn't have to make those investments in this complex AI, trying to figure out war games and all the secret spy stuff. And so the budget kind of went away. And then Ab Initio was kind of born out of the ashes of that to say, okay, maybe let's not do hardware because hardware is actually not the right place to invest. So we invested in the software to make things simple. And Ab Initio, if your Latin is a bit rusty, means from the beginning or from first principles. So if you're going to design the software from first principles, how would you design it? Separation of design and specification from deployment, scalability, the metadata-driven architecture of the software from day one. This is fundamental to how we sort of deliver value to our customers, and that evolved from the experience of this team working together for many years. And then my company, I was working with the team in Thinking Machines and the original ideation of Ab Initio. That company then got acquired by Teradata, and then I was involved in the IPO of Teradata on the New York Stock Exchange and with the company as CTO for quite some time. And then eventually I came back to Ab Initio, and here I am now.
It's beautiful. It's beautiful. And I think we have seen this development like brute force kind of, power, be it big data, data mining, or now the AGI. And then we find again, no, it's better if we also have the machines being more specialized, from monolithic design to microservice. And now I think with agentic, we see the same shift again. We see that even in superintelligence is doing hard to have the right context, because we as human beings are maybe also context-based. I mean, I can say, think of a house, and you think of a different house than I do, obviously. And then we also see that this principle works with agents. I mean, which is maybe a little bit of an overloaded term, but what is your vision for let's say the operating system of the future for a business, augmenting humans with whatever agents?
So I think that you will have agents that are specialized to different tasks.
Yes.
So the agent to automate the creation of data quality controls is going to be different than the agent for automating the mapping of source to target in an ETL processing. And that's going to be different than the agent that you use to have a conversation with data or to generate SQL. And so you'll have a workforce of agents with different expertise. And also at different levels of investment. So maybe for very sophisticated things, you need large language models. Of course, you have to pay more for that than, let's say, a small language model. For some tasks, you don't need the high-powered agent that has, lots of memory and so on. You can use a small language model that doesn't require GPUs, doesn't require a lot of memory. So you have some interesting trade-offs in the economics, the cost, in the amount of time it takes to get an answer back, and the accuracy of the answer. And there are huge trade-offs between the different language models. And my belief is that although today I see a lot of enterprises doing big evaluations of which language model are we going to choose, and there are two problems with that. One is whatever language model you choose today, within 12 months, it's going to be the wrong one.
Or 12 hours.
Leapfrogging going on all the time.
Yes.
The other thing is choosing one is not the right answer. You want multiple language models to coexist, aligned to different tasks. Just like in an organization, you have different humans with different skill sets and different trade-offs. So we need to think in the same way. And vendors, try to force you down a path of, pick my language model or, my tool and so on. And really you need to design for flexibility and portability
But why are people always falling for this again? Like, it's like, hey, I remember IBM Watson. It's like find the needle in the haystack with, and there's always like this fantasy of, you as a CEO, don't worry anymore about any of your business. Just buy our machine, buy our product, and it's going to solve all your problems. If you really are listening to yourself, it felt like, can this really work? Yeah, I mean, like, but why are
But
always
people want to believe. They want the easy button, and
The
you
silver
know,
bullet.
someone tells a very convincing story, and you want to believe it, so you buy in. But to your point, if you step back and say, "Does this really make sense?" In most cases, there's no real easy button. There's hard work. You have to think about it. You have to architect the right solution, and so on. And people want to buy technology because that's the easy button. And in the end, it's not the technology you buy, it's how you use it that matters. Of course, the technology does matter. Some technology is more scalable than others. Some technology is more effective for different purposes and so on. But unless you think first about what am I trying to do before you choose the technology, then you get into trouble. Because technology-led projects almost always fail. You have to have business-led projects, and then the technology is the tool for delivering those capabilities. At Ab Initio, we are, very adverse to traditional marketing because everybody says the same thing. All the PowerPoints look the same. What we try to do is get very quickly into proof of values where you actually do it, because doing is what matters.
It's a different story.
Not, do, don't talk. Don't show me another PowerPoint. Show me a working system that works on my data and my problem, then you have something that can work. So I think we're going to shift from what I would call cowboy experimental AI, people just trying to do this Silicon Valley resume building with all these AI tools on their LinkedIn profile, to the business demanding, no, we want to understand what is the business value proposition. If we do this, what is the outcome? And do I care? Not to do it for the sake of AI, the sexy buzzword of the day, but because we have business value and understanding which areas are going to commoditize, which areas aren't going to commoditize. And this is where the strategy comes in. You need to think about, where are you truly going to be differentiated? It is unlikely you're going to differentiate by having yet another AI-driven chatbot. That's going to commoditize. You're just going to be able to buy those off the shelf and do a little bit of domain-specific training, perhaps, and some other things that you would do to make it work. But you don't have to build that from scratch.
Yes.
You'll be able to buy that. So think hard about where you're going to differentiate and invest in those areas. And that has to do with your data products and your metadata context. Those things will transcend the different language models as they continue to improve. They will be independent of which particular technology platform. Those investments are the ones that are going to carry you forward.
I totally agree there, and I see that. I mean, like, the costs of having even a better language model now are exponentially increasing, even if hardware prices are still coming down. And on the other hand, the value you create is kind of decreasing, right? So how would you approach exactly this question? Like, imagine you're a German manufacturer of, I don't know, whatever tools or so, maybe do 1-2 billion revenue. So how would you look for the beef? How do you make this decision on?
Well, I want to come back to the point that you made about the value is no longer increasing as fast as it used to be. I actually think that there's a difference between using AI for automation, and then you have declining returns, as you described, versus transformation. The truly successful uses of AI are not just automation. Yeah, it's always good to do cost takeout for automation, fine, but that's not really what changes a business model. So look for transformational use cases, and there you're going to get exponential increases, and I think there's still a lot of potential.
I was just meaning that the development and of language models per se, like the foundation models. Yeah, I think this is kind of not leveled out, but I
think there's still improvements to be made there, but there's also some dangers, because we've done the training of these language models on all the open content on the internet and created a lot of knowledge from that. But now what's been happening is that there's new content being posted out there from the language models themselves. So there's inbreeding among the language models, and we all know what happens when you have inbreeding. It's the opposite of the diversification, and then you get not so smart language models coming out of it. So we have to be very careful at what the inputs are that we're using for the language models. Otherwise, we can definitely have this effect that you're talking about where there's decrease. But I think that from an algorithmic point of view, there's still a lot of opportunity to improve, cost and accuracy and so on. Those will continue to grow. I don't think they flattened out yet.
Okay, so you mean like DeepSeek approach or
that's one approach. That's kind of a small language model approach, but you need to try different approaches, and the use of the metadata context to improve the accuracy rather than just having more and more data in the training set. I mean, metadata in the end is not that big, but it's very powerful when used properly to do the grounding of the models and provide the guardrails and so on. And so, open our eyes to different approaches, not just brute force approach, but being smart is better than being strong.
Okay, so you mean, I didn't think about this. So it's giving more metadata quality, let's say, into the foundation model learning process itself.
Learning and execution.
Yeah. Okay, yeah. So again, like how would you assess the disruptive potential of AI for your business? Without being like too, fantastic, like, hey, in 10 years we all have flying cars-ish, but also not on this too linear, way of thinking, like let's cut 20% of costs and we are happy. So you want to make investments in AI like any portfolio. Some things you're going to make incremental improvements and your likelihood of success is very high, but the improvement is not huge. But it pays the electricity
automation.
bill.
That's it's self-funding, and in fact, it's better than self-funding. You can fund some of the other more advanced things, and so the next bucket would be, I'm gonna keep one foot pivoted, and then I'm gonna try something relatively new. So it's not some crazy rocket science idea. I'm still a bank, but I'm going to create a different kind of product with different way of thinking about things, or a different, financial advising through an AI agent or something like that to create, accessibility and democratize financial services. That's kind of a grounded. It's not as low risk as just this incremental improvement with automation. You're actually changing the business model and how the relationship with, in this case, the bank exists. And then and probably you should be investing, 60% in that. 30% in the incremental improvement, 60% in that. And once you're successful with that, and you won't always be, because your probability of success is, probably not more than 50%. It's okay. You're allowed to fail. You learn from the failures. And once you have success, then you move it down into the incremental improvement bucket and you look for the next innovation. And then 10% of your investment are the space shot ideas. And 90% of the time, they're going to fail, but it's okay. And maybe if you're a bank, you might not make these investments because banks aren't really interested in space shots. But a manufacturing company, they're going to manufacture something totally different. And that would be, that would maybe be interesting. And so you have to decide based on your risk profile how much money you put in each one of those buckets.
Perfect. Yeah.
Right. So it's a portfolio investment strategy in AI. And AI is right now a little bit confusing because people think that transformer neural networks is all of AI.
Yeah.
Generative AI is all of AI. Actually, no, AI is a big toolbox and there's lots and lots of stuff in there. And when people, come to me and say, we want to use AI, where should we use AI? This to me is the wrong question.
Yeah.
The goal is not to use AI. The goal is to create business value.
Yeah.
So let's brainstorm without talking about technology, without talking about AI. Where are the business improvement opportunities? Where are the opportunities for transformation in your company, for radically, changing the model for how you interact with customers or how we manufacture vehicles or whatever it is that you want to do? Let's think about that. And if AI is part of that solution, it likely would be, then let's use it.
But then people are a little bit disappointed, right? After you answered this to them, that's what I get. Like, so, but we were here to, talk about the transformative potential of AI. And why do we have to talk about my business like I do all the time with the consulting companies?
Because you start with the business, and then if you're well informed about what AI can do, then those opportunities, if appropriate, will surface. But it's not always going to be a transformer neural network. It's not always going to be generative AI. We might be using a convolutional neural network to do fraud detection and a transformer neural network to do process optimization. It might be using a boring 40-year-old logistic regression for doing things that is still the right way to do things. And using technology for the sake of technology is not the right answer. And,
it's so nice. It's so nice because I thought like the world should have gotten this. There's so many examples like with the nail and the screwdriver, and you see screws all everywhere because you have the most beautiful hammer, and you see nails everywhere, and you keep hitting the screws with the hammer because you have this beautiful hammer. But it's always happening again. It's I see some compounding effect on a basic, let's say, data AI literacy, like hype after hype, and some compounding effect also on data quality.
But those hypes eventually end up in crashes into what Gartner would call the trough of disillusionment, right? And right now, the AI hype is off the ski slopes.
Exactly.
Which means that when you fall down, it's going to hurt even more. And so we need to reset the expectations of what is realistic. I mean, people think that generative AI can do everything. Actually, it cannot do everything. It does interesting things to create content. It does interesting things to do process optimization. I would not use it to categorize it. It doesn't know how to do math at all, right? And
counting strawberries.
So, yeah,
ours and strawberry, or was it? Yeah,
that's the classic example. But just doing basic math, doing a forecasting model for what my revenue is going to be, no chance. Now, I might actually use generative AI to create agents that invoke other things through model context protocol. I might have other models using other capabilities. That's fine, but no one solution solves all the problems.
I think that's also like why we are still kind of may exist, because the alchemy, it's not, maybe it's data science, but it feels more like data alchemy sometimes. It's like you don't exactly know what happened, but maybe it would be gold in the end. And then kind of, this meta knowledge about also like what tools to use, how to have the agent interact, leveraging maybe also rule-based systems or physics informed. Is what I think is also very interesting. Like, why would you learn some basic math with brute force if you can, give this knowledge from engineering into the model already, or even have some rule-based systems?
I don't need a multi-level neural network to understand that 2 + 2 = 4.
Exactly.
Right?
Or how gravity
simpler,
works.
More cost-effective tools for doing that. But data science is fundamentally an experimental science, and I should be working with different sources of data, different AI algorithms to figure out the best way to detect fraud or to optimize the collections process or whatever it is that I need to do that's going to give value to my enterprise.
Beautiful. Let's look at the questions. It's, by the way, I love this. Yeah, maybe we can do this again sometime. Maybe a little bit about the use cases. So you've worked with like a lot of organizations around the globe. Is there any particular project use case or something that stood out? Like, hey, this was super cool. Nobody believed it was possible.
Well, at Ab Initio, there's nothing you can tell us. If you tell us something is impossible, that's like a challenge that we'll always go after, because everything is possible if you get enough smart people in the room and you get the collaborative juices going and so on. That's what we do. It's interesting. Like our customer support organization, most times people hate calling customer support because like somebody on the other end of the phone line is going to be flipping through a manual trying to answer my question. Our customer support organization, more than 90% have PhDs.
Wow.
In hard sciences typically. right? So these are really problem solvers. So, you know, they if you give them a question to look up in a manual, this is like the least interesting thing to do. They want hard problems to solve, and that's what really motivates the people. And so we look for those opportunities, and, you know, taking data from a multinational organization and bringing it together to you know, meet the regulatory requirements, and then reusing that data to create business value. This a data product, when designed well and deployed well, is not single use. It's, you know, many uses of it. One of the clients I work with, they call it the regulatory dividend. So I have to do the work to, let's say, enable BCBS 239 reporting in the banking industry. And if I check the box and I'm done, shame on me, because all that investment I made to understand the financial flows and the customers and risk and all those kind of things, that can also be used for doing my product pricing and my marketing and my risk analytics and so on. Shame on me if I'm not reusing those data products in that way. So for me, a complex organization that has lots of different data products and figuring out how they can interoperate and how they can be used with trust across organizational boundaries, this is huge. And so we work with a lot of, you know, very complex multinational organizations and solve those kind of problems.
What is a good level of the refinement, let's say, of a data product? Like, the question I'm coming from is, I didn't see so many data catalog projects be like super successful, because in the beginning it's empty and then it's super full, and then and what is a good level for a data product that it's, and how many data products should, that's a good question. How many data products should such a large company have?
So the data products generally align with business process domains. So I do kind of engineering from both sides. So one side is, how many business process domains do you have? Which typically, let's take banking as an example. Each product, typically aligned to some kind of line of business, is a business process domain.
So like a claims data
credit
product.
card. No, claims not really, because that's a business product. Think mortgage, credit card, direct deposit accounts, those kinds of things. So those are lines of business products. And then there are channels, so branches, call centers, websites, mobile apps. And then there are enterprise domains like risk, marketing, treasury, finance. These enterprise domains, they don't really create their own data per se. Marketing doesn't create their own data. They use the data from the operational business process domains, like mortgage and credit card and so on, to figure out the value of the customer and how to cross-sell and so on. Now, of course, marketing does create some data, like all the campaigns, et cetera, and measurements of conversion rates, et cetera. But for the most part, you're relying on the operational business process domains to see the data. Same with finance. Finance takes the data from the operational domains and then creates additional data like general ledger entries and so on.
The refinement is different because of the purpose of the use of the data, right?
But I differentiate between the operational domains and these enterprise domains like risk, finance, marketing, treasury. And then there are enterprise domains that align with, we would call it master data management domains, like customer, we might call it party, right? Because it's not just customers and prospects and suppliers and so on. So party as an enterprise domain, product as an enterprise domain, because each one of the line of businesses and each one of the channels cares about customer, party. So we don't want to replicate in that in all of them. So you want to kind of pull that out into an enterprise domain and then figure out how to collaborate on that. And it's like the enterprise domains are the hard ones.
Like you would put it in front of the bracket because it's more elegant. Like it would be, if it would be a equation, it makes sense to.
Yeah, I'd factor it out, let's say, which I think is what you're saying.
Yes.
And then you approach that as enterprise. And those are the hardest ones because you have to get agreement across the different lines of business. Now, the tricky part is people want to dump everything into that domain, everything about customer, their addresses. their credit card applications, that's about the customer, right? I don't do that. I say, take the minimum that you need in that enterprise domain, push all the rest in the line of business. So credit card applications, which has a lot of information about the party, I don't put it in the party domain. I put it in the credit card domain.
And then you have the primary key, which is like the name of the customer.
Exactly. Well, not the name of the customer. You have some surrogate ID that allows you to link them together across different names. So
but the name can change, or
exactly. Name is also PII data. So now you're GDPR violation because you're using
that was a trap. I was trying to put
that was a test,
European
right?
trap. Yeah. Beautiful. And you bring, like in your software, you have some templates or blueprints for that?
Yeah, in fact, we call them blueprints. So we have blueprints. The way we use generative AI to understand the raw data and the target data model, how to do the mapping. And we basically have blueprints that align to different ways of doing things, because maybe you have some data is streaming data that uses a different architectural model than if you're doing batch file processing, which is different if you're doing frequent mini batch processing. And so there are different ways of sort of getting repeatability, and we exactly call them blueprints. But we can create those automatically with the right metadata context. Mm-hmm. And this is
from the raw
breakthrough
data
that's happening as part of this, transformer neural network revolution that's happening.
Yeah, that's super cool. Maybe it's a bit too technical for everybody, but this is just beautiful. Yeah, and I love what you said before that. I mean, in the end, the leveraging data for the organization, especially if the data products are leveraged across the silos or the business processes. Because in Germany, we have a lot of product-centric companies still. Yeah, and when we want to make them use data to be successful with value, actually they have to think more about their clients, because they have to think value from the client perspective. This is like not just they haven't they haven't thought this through already, and the data is not its fault.
So
let's say, yeah.
line of business behaves as an island. I'm optimizing mortgages and you're optimizing credit card, but we don't look at total risk across those lines of business. We don't do cross-selling and so on. We're losing a big opportunity. And so that's why these enterprise domains exist for risk and marketing and so on. So you start to combine those. So coming back to your question, you should be able to write down each of the business process domains aligned to those things, and that gives you a starting point. And it's dozens, it's not hundreds. It's not a half a dozen either. Now, that's one way of sort of working at it. The other way I would look at it is, how big is your team? How big is the team is, I want to know the total number of people, because I'm going to have one team aligned to each business process domain. Mm-hmm. And the teams should be between 6 and 12 people. So we call this the two pizza principle. In Silicon Valley, you build teams no bigger than what you can feed with 2 pizzas.
And you have
American
large
pizzas. Big pizzas, right? 6 to 12 people, and I choose closer to 6 than 12.
Yeah.
But then you can start to say, well, okay, if I have X hundreds of people, you divide by, let's say, 8, and that gives you a starting point of how many teams can I afford to have. And on those teams, I need business people and technology people. I want integrated teams, agile DevOps best practices. So I want my data engineers, my data acquisition engineers, my data consumption engineers. I want a scrum master. I want the data scientist. I want the business stakeholder, all on the same team. And so I do those 2 pieces of math, all the different business process domains, and how many teams can we afford based on our staffing and what we might be able to staff with our future budget. And if they're very close, we have the answer. If they're very divergent, then you need to figure out how to iterate. And a small company might not have enough people to handle all the business process domains that a large company would. So if I'm a very small bank, I might combine all loan products into a business process domain. So car loans and credit cards and mortgages, that's all one business process domain, because it's all credit products of some kind. So you iterate that way based on the organizational resources, and you don't want to over-engineer and you don't want to under-engineer, and you have to do fit for purpose for each organization.
That's beautiful, because like normally in a data catalog, you would basically come from a more technical perspective and start with the columns in your database, let's say, and each variable. But we have to get a little bit further to, and I have so many questions more, maybe a little bit, because you also helped to shape the U.S. government's big data strategy as part of what's it, PCAST?
PCAST is the Presidential Council of Advisors on Science and Technology.
So how was that as a CTO, and maybe also like how do you think governments can evolve and leverage the power of data and AI?
Well, in that project, essentially, Barack Obama gave us, a dozen things roughly where he wanted to improve quality of life for U.S. citizens. Mm-hmm. And they were mostly obvious things: healthcare, education, energy, democracy, security, safety. There are no surprises. And this Council of Advisors, we were meant to go off and sort of think about these things and how we would use big data to improve quality of life in these different areas. So we essentially wrote a 200-page book or document, which is all public domain, and presented it as ideas of where investments should be made to improve quality of life in these different areas. And then the U.S. government makes investment in these areas, very often in cooperation with academic institutions or in sort of advanced research, commercial organizations, and so on. I'm not saying that every one of our recommendations was taken, but I could definitely see where we had an influence on how money was spent in terms of creating this capability. And, using IoT data and sensor data and using that. How would you use that for healthcare? How would you use that for, safety? How would you use that for energy, lowering energy consumption, et cetera, et cetera? So we sort of brainstorm about these kind of ideas and laid out an investment plan for making this happen. There were, roughly a dozen of us, mostly from academic institutions, large universities within the U.S. I was one of, only 3 what I would call commercial CTO types. The rest were like hardcore, professor, tenure professor academic types. But it was a very interesting group of people, and I'm kind of a semi-academic anyway. And so we had a lot of interesting discussion and heated arguments in a very productive way to decide what we were going to make these recommendations and how to think about allocating funds to these, from a government budget perspective.
That's very nice. Like maybe closing a little bit. So how do you see the world play out with the power of AI? Huge question. Yeah, I mean, like a lot of things going on in the US. Europe is kind of finding its way, maybe-ish. Asia, it depends on where you are. But China pushing things now. Where do you have any prediction? I mean, it's hard, I know, especially if it's about the future. But
it is hard. I distinguish. There's a very good book called Power and Progress. It's written by the Nobel laureate in economics that won in 2024. And he's an MIT professor, and he wrote this book, and he talks about good AI versus bad AI. Bad AI takes jobs away from humans and creates obsolescence in society for humans. Good AI allows humans to have skills that they wouldn't have by themselves and empowers them to do more things and better things and so on. So as a society, we need to think about, good AI. How can we use AI to augment the intelligence of humans to make them more productive and give them skills that they wouldn't have by themselves, rather than trying to make humans obsolete? So this is kind of the difference between this, automated intelligence, which is kind of incremental improvements, but it's not game-changing for an organization, versus augmented intelligence, where you're really transforming the way things get done with the introduction of new skill sets. But there are going to be jobs that are lost, right? I mean, if
It's
you
always
look
been
at
the case, right? I mean,
it is a kind of revolution, an industrial revolution, using AI. And to give a specific example, more than 50% of the males in the United States with no college education drive for a living. Taxis, Ubers, delivery trucks, trains, forklifts, whatever. Those jobs are all going away.
50% of males
Over 50%
in the US.
of males with no college education.
Wow.
So that's huge.
So how many people are this? Like how many don't have a college? Do you know that?
I don't know the number off that, but it's
like 30 million people.
Yeah, it's a lot. It's a lot.
I don't know. Wow.
I mean, it's definitely millions of people, and so those jobs are all going away. If you go to, I'll say, a modern city, Los Angeles, San Francisco, Austin, and so on, there are already driverless cars going around as taxis. Drivers are being eliminated. Those jobs are going to go away, and we have to give those people new skills. And we're not going to give them new skills necessarily by sending them to college, because college is not the right thing for everybody. And they obviously chose not to go to college. So let's think about other ways which we can empower them and give them the skills to use AI so that they can do things that they couldn't do before, that allows them to be productive in something that is interesting and doing knowledge work without necessarily sending people to university who aren't interested in that. So we need to think out of the box. People need purpose.
But is this like, I mean, the American rethink way would be more like the invisible hand, like the market will figure it out? Or who's responsible of basically helping those people? I think that's my question.
Well, I think as society we have responsibility, and obviously government has a role in that. But you say the market would figure out. I think that's also important. The market's going to figure out that these people are, they want a sort of empowered existence. And so it's in our best interest to give them the tools to be empowered so that they can be productive and they can contribute to the creation of value. If they just sit at home and we give them some minimum sustainable income, we could go down the path of taxing the AI giants and taking their money and redistributing it to all the people that they put out of a job. Those people receiving that money are not going to be happy.
No.
There have been experiments, for example, in Finland that showed that this is not a good outcome. We want to give people purpose, and it's actually good for society as well as for those individuals, for those people to have purpose. And creating good AI that allows them to have skill sets that they didn't have before is the right thing to do for everybody involved.
I think the problem here in Europe is that, I mean, it's getting better, but still it's like we are thinking about regulating this kind of environment, right? And then basically things are happening without us-ish. Yeah, then like even Apple Intelligence launched. Did they even launch in Europe? I don't actually know, but they launched much later, if they even did. It's like, so how do you see a good approach between a socialistic approach, which is like government controls it, and it kind of spies on people, versus we have this in Europe, this idea of the kind of mixture between both worlds, and then more the free market. Like, is there a superior kind of governance structure to do that, or
it's very cultural? So historically Europeans, and I'm generalizing, of course, Europeans trust government, they don't trust industry. The U.S. doesn't trust government, they trust industry.
But is
it's culturally
because of the Civil War, or where's it coming from?
Not to get too political, but you just have to look at the political landscape in the U.S. in recent years.
I don't know what you mean.
People just don't have trust in government. They believe that in capitalism. They believe in the market forces will cause the right things to do. That does not mean there shouldn't be some regulation. You can't have too much power concentrating in too few people, because then monopolies create distortion in the sort of economic value creation and how the value gets distributed.
Right. I think we can agree that whenever power was too dense, it never had a good outcome.
Exactly.
Right? Like
exactly. That's the monopoly kind of scenario. The problem in Europe is government doesn't actually have the charter to create value. Government wants to regulate. And so government in Europe tends to over-regulate at the expense of value. The U.S. tends to over-commercialize at the expense of, I'll say, protection of certain portions of society. And so there's some very tricky trade-offs. I don't think there's one right answer. It's very cultural. But people. I've sometimes been asked. I was actually in a forum, a workshop in Frankfurt, and they were sort of going down the path that you're going. Oh, the problem with Europe is too much regulation and not enough innovation, and there may be some of that, but I think there's another thing going on, which is culturally, Europeans and actually Germany in particular is very risk averse. So in Silicon Valley, that's where I'm born and bred in Silicon Valley. Failure is not a bad word.
Yes.
Failure is part of the innovation process. So if I go to a venture capitalist, I say, I have this great idea, this new startup company and so on, and well, yeah, I failed in my last one, but I learned these things, I'm going to do it better now. The venture capitalist would rather invest in them than someone who's never done it before.
Was never failed,
But in my experience, having worked in Germany for many years, is very often failure is punished.
It definitely, especially in large corporations, you get promoted if you don't have a scratch in your paint. But
then that means no innovation is taking place because nobody's willing to take a risk because it's better just to stay the course and get promotion based on how long I've been tenured in the company, et cetera, et cetera. And so I think that in this workshop, someone asked, and I was there are a bunch of German executives and me, and they asked, in Germany, we have a great engineering culture. We have great universities, lots of smart people, hardworking people. Why don't we have Silicon Valley? So everybody looks at me. I say, I agree with all those things. Great engineering culture, smart people, good. All those things are true. It's because you're afraid to take risk. And if there's no risk, there's no innovation. Failure is an opportunity to learn. Yeah. It's not a bad thing. Now, if you make the same failure multiple times, you're not learning, so that's a problem.
That's the bit, yeah.
So there needs to be knowledge management and learning and so on, but failure is not a bad thing, as long as it's fast and cheap.
But where does it come from? Because it hasn't, I was born in East Germany, right? And things were very bad, obviously. That's why it broke down, unfortunately. And then we had nothing to lose, kind of being refugees from Leipzig to coming to Bavaria and everything. But is it this complacency? Because I also remember my grandma talking how they built up, after the Second World War and everything. Has it always been the case? Is it in our genes or does it?
No, it's culture. Think about the culture again. It's governments regulate, and governments are fundamentally risk-averse.
But we vote the government-ish, right? It's the people who choose the government.
Yes, but if you put more trust in the government, you're putting trust in regulation, and you're basically risk-averse. Whereas if you put trust in commercial enterprises are about value creation. They're not about regulation. Commercial enterprises are less risk-averse than governments. And so it's a cultural thing that happens.
Interesting. That's very nice. We have to stop. It's just I'm so grateful that you're taking the time after also a long conference day today here in Munich. Maybe closing up is, what do you want to see for the future, or what are you excited about? You have this drive, and I guess you will continue forever. Looking at your wife here. So what still excites you, and what do you want to see in the next coming years?
So for me, the things that excites me the most about AI futures is changing the healthcare landscape.
Oh, yeah.
I'm less interested in using AI to sell stuff to people that they don't need. right? That's, I know commercially people want to do that and so on, but I'm much more excited about using AI to discover new treatments for cancer, new ways of delivering healthcare, ways of sensor enabling the body, and collecting that data and doing very precision medicine, not treating everybody the same, but really individualized medicine based on algorithms that cannot possibly be understood by humans, but with doctors and AI working together to deliver the next generation of healthcare. That to me is groundbreaking possibility. We're at very early stages. There's a lot more out there that we can do.
Beautiful. Okay, so thanks for taking us, Stephen, on your journey of AI, and we went back to the past and we looked into the future, and we discussed very many aspects of how AI is changing the business landscape, the culture, how it enables or maybe hinders, and also the political things going on. So I think we made a big round going some deep technical things as well. So thank you very much, and also for you, a symbol of what we talked about. Thank you very much for taking the time.
It's funny that you presented this car from Back to the Future, because very often journalists have compared me to Doc because I have this crazy hair and crazy ideas and so on. So it's very appropriate.
Arguably some similarity. Thank you very much for your time.
Thank you.
Yeah.
Thank you.
Thank you.